Okay, for today, it's functions versus relations and a little bit of domain and range. I want you to go to this slide right here. And do you get that on the top picture? Functions are a subset of relations. That's trying to say is almost everything out there that's a pairing of two numbers is a relation. But only some of them are functions. It's a smaller group of them that are actually functions. Okay, I'm going to move to this next. There's three ways to determine whether or not something is a function. You'll have to know all three, so pay attention. Don't just know the vertical line test. That's a good one. How many of you that rings a bell? You remember the vertical line test? All right, if you don't, I'm going to take a second and tell you about that. If I take a function and it looks like this, if I take a vertical line, which would be like this green line here, and I move it across the function, does it ever touch it twice? No, it doesn't, and therefore that was a function. Whereas if I drew not that blue line, but instead like a circle here, would that be a function? No, because you could put in something like 0 for an x input and get two y answers. If you're getting two answers at once, if that vertical line touches twice, then it has failed the vertical line test. That is one of the best ones. It's for testing if something works or not. If they give you points like this, honestly, you can just graph them and then turn it into the vertical line test. And if it passes the vertical line test, that works too. But this point method goes like this. If I put in a 1, I better only get one thing out. That's like putting this line in here at 1. See, it's failing because it's giving me two answers. It's giving me an answer here and an answer there. So if I put in the number 1, it better not give me two answers. Here, I put in the number twice. Did it give me the same answer? No, it gave me two different answers. So that is not a function. This would be not a function because of this was different one time. When you put in 1 as an input, you better only get one thing out. All right. And then the last way to tell if an equation, if a function is a function or not, is when you solve it for y, it better only have one rule. Like, I just showed you a circle a second ago, right? Do you remember that this is actually the equation of a circle? That is how it looks. X squared, and then plus or minus a y squared, and then equals a number. And this one's got the radius built into it. That's like a 2 squared, right? So that would be a circle that has a radius of 2. Well, anyway, we already know the answer. Is this thing going to be a function or not? No. But here's how to tell by using the equation rule. If you solve it for y and you get only one answer, then it's a function. So let me show you how if I solve this thing for y, now I got negative y squared equals negative x squared plus 4, which is the same as 2 squared. I'm almost solved for y. Now I'm going to multiply everything by negative 1. That makes this positive, positive, and makes that negative. Y squared equals x squared minus 4. And then if I solve it wrong, like a lot of people do, and think that, oh, well, I just take the square root of this and the square root of that, and y equals square root of x squared minus 4. If I solve it wrong like that, I would think this was a function because it's only got one answer for y. But what actually happens when I square root a variable, you get the absolute value of y, and that means you will get two equations. Y equals square root of x squared minus 4, and y equals negative square root of x squared minus 4. If you're not paying attention to me on this, it's going to burn you, I think, 5 times on 5 different tests. When you square root a variable, you get an absolute value. If you just keep on saying, no, I'm just going to do the plus minus thing, you're going to get it wrong 5 times, and I will, by the end, be crying a little bit when you get it wrong again on the 5th test. You've got to get this in your head. Square root of a variable gives you absolute value. So now I've got 2 equations. What does that tell me? Is it a function or not? It's not a function if it's got 2 equations. If it only has one equation, it's a function. All right, so let me give you an equation. You tell me, function or not. 2 comma 3 and 5 comma 7. From what you know, is this a function or not a function? That is a function. From all the information we have. All right, what if I add one more point? 2 comma 9, function or not a function? Not a function. And if you had graphed them, you could have used the vertical line test to tell. Over 2 up 9, over 2 up 3, holy crap, they would not pass the vertical line test. It would fail. So therefore, vertical line test can help you, or just knowing one input should have only one output, not two different things. All right, and the last way would be, here's an equation, function or not. Yeah, you just tell by looking at it, because it's solved for y and there's only one equation. That is a function. Get how powerful that is? It's really important. If somebody gives you something complicated like this, you might think, well, I got to graph it and see if it passes the vertical line test. No, you don't. If you've got one equation solved for y, you can tell it's a function. All right, how about now? Function or not? Not a function, because when you square root this to solve it, unless you think you can just get y here, you get the absolute value of y, and which will give you two different answers, which means it would not be a function then. All right, that's is it a function or not part. Next thing is about domain. If I give you a picture of a graph, you should be able to tell me its domain and its range. Let's say this is the spot 2 comma 1. That right there is 2 comma 1. And let's say this is the spot over here of, let's say that's out 12 and comma, let's say it's up 10. 12 comma 10. Would you please write down what you think the domain and range are? I want to see if you know this already, or if this is going to be something brand new for you. You may write your answers as interval notation. Like 3 comma 9 is my domain, and blah, blah, blah. Domain, range. All right, domain is all about the x's. Do you get in this case? It goes from 2 to 12. And it can't be 2, though. It's got an open spot there. Did you notice that? As opposed to if this was filled in, then 2 worked, but it wasn't filled in, so it did not work at 2, and it did not work at 12. The brackets versus parentheses are a big deal on this. Okay? And then the range is the y's, and your y's went from 1 to 10. And again, I had empty spots there. Raise your hand if you actually had that right in the first place. Wow, a lot of you. Nice job. Then I'm just going to up the difficulty level a little bit. What if I fill that in? Now, what's your new domain and range? Because it's different now. Yes, sir. Brackets on the 12 and the 10. You are correct. All right. That's domain and range of something where you have a picture. All right. What if you have an equation? You know what the easiest thing to do is? Make it into a picture. Okay, because otherwise you got to do these complicated things, and especially the range. We don't even teach you that. We just say, visualize it. Do you remember what it looks like? X squared plus 7? It's a parabola, but up 7. So do you get it? Pretty much looks like this. Now, what's its domain now that I look at the picture? Domain is x's. Doesn't it go forever this way and forever that way? Or does it like stop somewhere? It doesn't stop. It goes forever. So what's its domain? Negative infinity to infinity. And What's its range? Does it go forever downwards? No, it has a lowest point. I better tell you what it is. Well, I can look at the equation and see what it is. 7. Range goes from 7 to, well, how high would it go? Infinity. Now, can you ever get to infinity? No, so you put a parenthesis. Does it ever get to 7? It does, so I'd put a bracket on that. There's how to do domain and range of an equation. You basically just graph the equation, and then you do it from the graph. All right. I'm going to pause for a second. Unpausing, and now I think we're ready to show your homework. And everybody find in the file some homework problems near the end. Pause it. So on these, they just want you to say, is it a function or not? And basically, it asks you to find the domain and range of the ones that are functions. So it's really great when you can say, oh, not a function, because you can be done then. If it is a function, you got to say what's its domain and range. Well, if there's a whole bunch of points, well, figure out what the, I guess honestly, I would probably just graph it really quick and then figure out what the lowest is to what the highest is. Domain is how far left it goes to how far right it goes. All right, but let's look at this first and see quick. Is it a function or not? Really what you got to do is, can anybody prove it's not a function? By looking at an input and seeing that same input again with a different output. Ooh, yes? Correct. That right there proves this is not a function. So you can just say not, and you're done, and you move on. Okay? This is using set builder notation. It's saying that x is an irrational number. What's an irrational number? Well, rational means can be written as a fraction. That means things that can't be written as fractions. That's weird. What's something I can't write as a fraction? Pi. Good. And n the square root of 2. Those are good examples of irrationals. So then the question is, if you have something comma 1, where the somethings are square roots that are weird, and pi, comma 1, is there more than one, if you put in an input, will it have more than one output? Another way to think of it is graph those things. Here's pi is about 3.14, comma 1. Here's the square root of 2, which is a little less than that, comma 1. Does it pass the vertical line test? Yeah. Here's another one, comma 1. Here's another one, comma 1. Here's another one, comma 1. You getting the idea? I like to graph them and then see will it pass the vertical line test. That's, to me, my go-to way. All right, so if that does pass the vertical line test, it looks like it is a function. Now, if it is a function, we're supposed to say the domain and range of them. So, what's the smallest xy's that this would ever be? Can there be negative irrational numbers? You actually can. You just put a negative on a negative, like negative pi. That made it a negative irrational number. Okay, so there are negative irrational numbers, and so therefore they can be infinitely small or infinitely big xy's. But how about y? The range of this thing. Do you get that it never, height-wise, up and down-wise, it never changes. What is the range of this? It goes from 1 to 1. All right. Your assignment is listen, because you're obviously shut your iPad, so listen. Your assignment is this first page and this second page. And I will let you skip the rest. Just the first and the second page of your homework. Have a good day.